So RAN, as we call, as we discussed earlier, radio access network. This is the critical component of wireless communication system, right? So it provides coverage and connectivity to mobile devices. There are several different RAN architectures available today, and each of them has a unique strength and trade-offs. So ultimately, the choice of RAN architecture will depend on the range of factors. So it may include the specific use case or network topology and available resources and the performance requirements. So operators can optimize their network performance, improve efficiency, and deliver high speed, low latency, and high reliability data transfer. Okay, as required by 5G applications. So RAN also evolves. No? So we're now discussing about the evolution of radio access network. So this is a different set of evolution because the first evolution that we have discussed is the 1G to 5G. Now we are talking about the evolution, particularly of the radio access network architecture. First, we have this what we call the traditional network. We call it the DRAN. Okay, the DRAN or the distributed RAN. So we call it also the traditional network. So if you hear something about DRAN, we are referring to traditional network. DRAN means distributed RAN. So why is it called distributed? So this is the traditional RAN architecture that has been used for many years. So simula pa nung dineploy yung mga unang technology like 2G up to LTE, no? Meron pa tayong DRAN yan. Actually, sa Pilipinas, most of our deployments are DRAN or the traditional network. Okay. So it consists of separate baseband, okay, baseband units and radio units which are connected via dedicated fiber or copper cables. And yeah, so the cell sites or the baseband and the RRU are located in the cell site premises. So same like this, no? Yan. This is a distributed RAN. So yung ating mga baseband unit, okay, yung ating mga baseband units, radio units are located inside the premises of the cell site. So we call it the distributed RAN because we are distributing, no, yung mga RAN sa iba't ibang locations, no, ng ating mga cell sites. So that is the traditional network. And then it evolves into a centralized network. Yeah. A centralized network, in this architecture, it emerged in response to the need for more flexible and cost-effective solutions. So it uses a centralized processing unit to support a multiple remote radio heads, okay, which are connected via high-speed fiber optic links. Okay. And this approach can help to reduce cost and improve network efficiency. So what happened here is that the baseband unit previously located at the premises, no, in the premises of the cell site, now located in a central office. Nakapool na siya. So we call it the baseband pool. And in some terminologies or some references, you will read it as a baseband hotel. So we are having some jokes in the RF engineering. Buti pa raw ang baseband in a hotel. Okay. So meron siyang baseband hotel. Okay. Yeah. So those basebands are pulled together in the central office. So for the ease of maintenance, okay. And of course, this is also using a fiber optic. And some of the fiber, we call it dark fiber, yung mga spare ng mga operators, they are using it to connect this RUs to the baseband pool. Okay, so the BBUs are pulled in the centralized location, and the site only has the antennas and the RU, and the BBU, RU, and interface are proprietary. Ibig sabihin, yung mga protocols niyan is still under the control ng existing vendors natin. And then it became virtualized network. Yan. Okay, virtualized network. So virtualized network in this architecture builds on the benefits of the CRAN. Actually, it's a CRAN as well, but it's a different case na, no? It adds the virtualization technology, okay, to further improve efficiency and scalability. By using a software-defined networking and network function virtualization, so meron tayong separate discussion about SDN and NFV technologies under Open RAN pa rin yan, under Asia Open Academy pa rin yan. And it creates a virtual network functions that can be rapidly deployed and scale as needed. Just imagine last time, dati sa traditional network, like for example, no, I will activate additional capacity or additional carrier of LTE. What I need to do, the site engineer needs to go to the premises ng cell site, insert the board, or like for example, the additional LTE board to activate that carrier. So kailangan niya pumunta pa sa site. So he needs to go in the cell site premises. And then centralized network, ang mangyari kung kailangan nating mag-upgrade ng site, so the engineers don't need to go in the cell site premises. Saan siya pupunta? Dito na lang sa central office where he can upgrade, okay, switch sa boards, no, dun sa pinaka central office, and then activate the LTE. So, but this time here, dahil virtualize na tayo, if the operator wants to increase capacity or to direct traffic, no, he can do it without physical intervention dun sa equipment. You can use also virtualization only, just adding command only, and then create a new instance of the network. And then if that instance is not needed anymore, you can just delete it. Okay, so ganun yun. Para kang, just imagine it like an app in your phone. For example, you want to listen in the Spotify. What you will do, no? You will get your smartphone, download the app, install the Spotify, and then listen to the music. Now, if you don't want to listen anymore, and then you want to delete that app, just click the delete. So that's how flexible it became. So that kind of concept is being applied in the telecom world, and then we call it the virtualization. Okay. So the main challenge here is that the software is still proprietary with virtualized function. So you can still the product is still proprietary coming from the different vendors, and the interconnection is still proprietary. Okay, so that's how the virtualized network is happening. You can install the software or configure the software in a COTS hardware. Okay, commercial off-the-shelf hardware. You can buy a server and then install those virtualized function there. But the interconnection is still proprietary. Okay, so it's still not open. Okay, so it's proprietary interface pa rin. And then the Open RAN. Okay, so the Open RAN, now we have the core network. Your baseband unit is now separated into centralized unit and the distributed unit, and then you have the radio unit. Okay, so there's a separation. The functionality is already split. And then the cloud native network functions and the GPP hardware, meaning you're also using a GPP, general purpose hardware or COTS hardware, and the software defined networks, and the interfaces are open, meaning you can mix and match different vendors to the different vendors of the RU to the CU or the DU. Okay, so this is how the Open RAN is different from the virtualized RAN. Okay, so you remove the proprietary factor, no, dun sa mga equipment natin. That's how the Open RAN differs from from this different radio access network. Okay? So ano ba yung mga COTS, no? When we talk about COTS. So pag sinabi natin COTS, so it's commercial off the shelf. So it's a software term for software products that are ready-made and available for purchase. And the BBU gets replaced by COTS server rather than being proprietary BBU hardware. Previously, so that you can also relate, no? If you want to buy a radio, if you want to listen to FM or AM radio previously, you need to buy a radio. Right? Buy a radio, physical radio with an antenna. And then you tune it and then you listen to your favorite station. Okay. Now, you can listen to radios or FM radio particularly, even though if it's just a simple application only and then connected to the server or to application server nung radio station na yon. So you don't need to buy the radio. You can just have the phone and then install the software there so you can use and then enjoy the benefits of the functionality ng radio. Ganun din nangyayari dito sa Open RAN. So you don't need to buy the baseband unit. You just buy a COTS server and then just configure it of the functionality of the baseband functionality you want to implement in your network. Okay? And proprietary interfaces between radios and COTS base remain as they are. Okay? And so you can connect different vendor of RRU to different vendor of BBU. So that's how the flexibility of Open RAN is. No? When we try to see some application like this, no, sa mga testings ng mga Open RAN system, you can see in the test systems that there's a separate BBU and then there are different RRUs that they are testing if it is working, interoperable to each other. And sometimes there's a one RRU and then you connect a CU. You can check the different CU to check the interoperability. So tinetest nila yung mga interoperability ng bawat vendor sa isa't isa. So that's one of the applications niyan.